Hello, my name is Jeff Aldrich. I'm a manager of technical support and service, and in association with your regional technical managers, we have provided you a instructional video on how to maintain and operate your Eli helicopter ride, and we hope it's informative, and here it is.
Okay, Chucky's going to demonstrate the theory of operation on the Memo Park Eli ride. He's going to drop a coin into the coin box, engaging the coin switch. Once the coin hits the switch, the audio starts up. The ride begins to rotate. As long as all safety devices have been met while the pedals are being turned, the ride should raise up. There's a sensor on the back side of the ride, a proximity sensor, that's sensed by the rear pulley. While the rear pulley is turning, it sends a signal over to the CPU, raising the ride upwards. While the ride's going up and down, notice also the headlight blinks and the floor lights come on. And in addition to that, while the pedal is being cranked, the rear propeller turns and the upper propeller turns. After the ride has reached its most upper limit, it should take approximately 9 seconds to descend to its most lower limit. That can be adjusted with the flow control that's located under the rear speaker cover.
Now let's go over the safety features. These features must be checked daily. The ride should not go up if the seatbelt is not fastened. The ride should have 6 clear spacers installed at these locations. If the black box is touched, the ride should stop. The black box cover should have either black or white spacers installed to prevent any fingers from getting caught as the ride descends. There should be 3 photo sensors on the base of the ride that activate when the beam is blocked. There are also sensors located underneath the ride that activate when someone touches the safety bar. A fiberglass cover should be installed at the base of the ride to prevent anything from getting caught as the ride rotates. The rotation speed should be set at 8 for minimum and 8 for maximum.
This is your pump motor, okay, and this is your pump manifold, and this is your reservoir, and inside the reservoir is where the pump is. When you fill this, you want to fill it about 1/2 inch from the top of the fill hole, and you want to only use a mobile DTE 24 hydraulic oil, which crosses to a Granger's 3KD 75. That's 3KD 75 at Granger's. If you notice, there's 2 lines here. One line is your return line for pressure to escape from the back of the cylinder, and it returns right back into your reservoir. And then this line, the larger of the 2 lines, is your pressure line. So your pressure comes out here, goes to the bottom of the cylinder, and comes back. And then if there's any residual pressure or fluid, it leaks back through this line and then returns back to your reservoir tank. Okay, this is your pump manifold, and mounted to the side of the pump manifold is your 24-volt valve that's being controlled by your CPU board on the ride that's mounted just below your cash box door. It operates off 24 volts, and if you wanted to check it, there's a couple of ways to do that. Okay, this is connector J4 that's plugged into your CPU card on the middle left-hand side of the board. It's a 4-pin connector, and you count the pins from left to right. So normally it would be on your board like this. Pin 1 is here, 2, 3, and 4. Pin 1 is the one lead to your coil. Pin 4 is the other lead. The 2 yellow wires are going to your home switch for your rotation, so we're not going to concern ourselves with that now. When we read across that, you're going to read anywhere from 30 to 40 ohms. And that's reading directly. So when you're doing that, you're checking both your wiring from the CPU board to your coil, and you're also testing the coil itself. Now that's just the coil. Your valve itself still could be bad, but generally when this fails, it's going to be your coil more so than the valve. The larger of the two lines, the pressure line, when you point up your ride and J3 clicks in, or the relay at J3 clicks in and sends 120 to your pump motor, your pump's going to start. It's going to send pressure on the larger of the two lines. It's going to go directly to your 110 valve, and that's this valve here. Yet the sole purpose of your 110 valve is that if ever your ride should lose power at any moment while the ride is up in the air, the valve closes so that any pressure that's remaining in the cylinder is trapped in there and is not allowed to return back to your pump. So the ride stays up and doesn't come crashing down on anybody. Okay. This 110 valve gets 110 directly off the power cord, off of these two wires. So it's there all the time. Whenever the ride's plugged in, this has 120. Okay. If you want to take that apart, there's a screw on the very end of it. You can unscrew it, and then the valve itself will come off. If you want to take the coil part off, there's a screw right down in the center. I've already taken that off, but that just pops right off. When you do that, you're going to be able to take the coil itself off. And you're probably going to be able to reach all this because on the base there's a speaker cover just about in this same general area. You can take that speaker cover off and usually gain pretty good access to this valve. Once you do take that off, a lot of times when this coil goes bad, it opens circuit. So all it is just an electronic coil that when it becomes energized, it becomes magnetic and it causes a pin to push inside of it and open up. Okay, as long as that valve becomes open, fluid is allowed to pass through it and get to the lift cylinder and make the ride go up. To check it, you just take each of your meter leads and go across the two pins. When you do so, you're going to read anywhere from 360 ohms to 640 ohms. This one here reads 638 ohms. Generally, when they go bad, you read infinite resistance, almost an open circuit. Okay. Another thing that can sometimes fail on these is if you notice on the top, it has a diode symbol. And it just kind of pops off much like this. And you have to kind of feed the wires into it from the top. Once you do so, you're going to find that there's a little network of diodes forming a bridge circuit, or bridge rectifier circuit. Sometimes if the diodes fail, you could be getting 120 here, but because the diodes have open circuited, you're not going to get the 120 to the coil itself and make it energize. If it doesn't energize, you're not going to get fluid to your cylinder. If you don't get fluid to your cylinder, your ride's not going to go up. Okay? If you find that that's gone bad, you just get a replacement from the Chuck E. Cheese parts department. But you do, if you also wanted to check this, what you can do is your meter leads won't fit into the holes. So what you can do is stick the partially in there and leaving yourself just enough room to get your meter leads in to where you're making contacts to the pins. And you should read anywhere from 90 to 100 volts DC. Okay? Because your bridge rectifier circuit's breaking down that 110 to a DC voltage. Okay? When you're all done, you just slip it all back on. Many times when this does fail, it's just the coil that's failed and not the valve itself. So you can just replace this and generally usually get your ride going again. Okay. Right next to the 110 valve, you're going to find a gold-colored valve that's right here and has an adjustment knob on the top. And the sole purpose of this valve is to adjust how the rate that the ride descends from the top. It won't adjust how fast it goes up, just how fast it goes down. And if you're having a problem where the ride's going up too fast or you're adjusting and it's adjusting how fast it's going up, then you probably have the valve turned backwards. One other thing that I forgot about on this 110 valve is if you do replace it, sometimes you're not sure which way it goes, and it does matter. There's a little P on one side, the P side goes to the pump. That's what the P represents. So you want to make sure the P goes to the side that has the thicker hose on it, to put it in correctly. Also, if you should have to replace this valve and you're not sure which direction it was in originally, a key point to remember is that one end is longer than the other. One end is about a half an inch long, and the other end is about almost 2 inches long. So the shorter end, or the half-inch end, goes closest to the 110 valve itself. And that will ensure that you're putting it in the correct way so that it adjusts how fast the ride descends. On this assembly here is the back frame called the inner frame that makes your ride go up and down. And on the very top of the assembly, if you notice, you're going to have a single wire and then these red insulators. Okay? These insulators, what they do is they insulate this wire from this metal frame. This metal frame is grounded because it's attached to your entire frame. The signal that drives this pin is any kind of ground contact, which is the outer black box that kind of surrounds this assembly. If this goes to ground, it activates your black box sensor circuit and makes your ride stop. So we want to be sure and check continuity from this pin to this frame here and make sure that it is insulated, that you don't read any shorts between here and the frame. Okay? And that's what these red points here act as an insulator. Okay, this is your lift chain here that makes your ride go up and down. This is your lift cylinder that acts on this pressure point here. What you want to be sure when you're doing your visual inspections or PM of your ride, you want to make sure that this shaft is firmly affixed against this drive mechanism here so that it doesn't cause your seals in your cylinder to prematurely fail or wear unevenly. So that's another visual point you want to make when you're doing your preventive maintenance. You also want to check up in this area up here, make sure that there's no sawing of the chain onto the side brackets that your sprocket goes through, that it's not wearing into that. If you see evidence of that, you want to take care of that right away, because it could eventually, if not taken care of, will cause your chain to break, and which would be cause serious problems with your ride. This cable that you see riding here is your bike connector cable that actually fastens and clips on to your bike mechanism. If your chain should ever break, this will probably tear apart and you'll need to replace it, and you're talking about a very labor-intensive repair. So by making these visual inspections, you're going to save yourself a lot of time and effort in preventing this type of failure to happen. So you really want to make sure that this is something you do on a regular basis. Okay, when you're lubricating these U-frame brackets that your ride travels up and down through, you want to use like a white lithium-based lubricant, which is called Lubriplate, that you can get through the CEC parts department. And you just want to lubricate the inside of that. And basically, what you're trying to accomplish is you want to limit the friction between the bearings and the metal frame of the ride. And by doing that, you're just going to cause your bearings to last longer, and also your inner frame to last longer. So a little bit of effort when you're doing your monthly or PMs, it's going to save yourself a lot of wear and tear on your assembly.
Action.
Okay, as you do your monthly visual inspection of your ride, you want to make sure that there's no evidence of wear between the chain and the two brackets here, and then also down here at the bottom, because the metal pin is a little more heavier than the bracket itself. So you may see that. If you do, then you want to contact your regional technical manager or technical support and let us know about that. You also have your pulley here, and again, here's your chain or your wire for your black box sensor circuit. Some stores are taped, much like it is down here at the bottom. And if you do have it taped, don't tape to this side. Make sure you tape to this side and tape it all the way up to the top of your assembly. Another thing you want to check when you're doing your inspection is there's a master link here that kind of clips on and clips off. You want to make sure that that's not missing or damaged in any way. And you just want to visually inspect your entire chain for any evidence of cracking or wear or anything unusual about the chain, because that's something that can cause you some serious damage to your ride. And you want to make sure that that's always in good shape. You have another wear point here. If your chain system, for whatever reason, should come too close to this, and it'll eventually cause a sawing action into this metal piece here, you want to watch for evidence of that as well. Your lift cylinder is here, and you want to make sure this is the shaft of your cylinder, and it rests to this metal piece here, and that's what's actually drawing your ride up and down. You want to make sure that is as flush or flat against this metal post as possible, because that's going to cause your cylinder to wear evenly on the seals that are inside of the cylinder. If you should see leaking coming out the sides, the best thing to do is replace the cylinder. It costs about $130 from the parts department, and you just replace it by removing the pins down at the bottom, and then your brackets are here and here. And this is another item to check regularly in your maintenance, and you may even want to replace them with nylock nuts, but check and make sure that these haven't loosened up, because if it does, it's going to cause that cylinder to move forward or backwards, and then cause the nose seals to have evidence of wear and cause your cylinder to fail prematurely. And
Hi, my name's Troy. I'm with the Western region, and today I'm going to explain the gears on the Eli. I'm going to explain the most common problems and then work down the machine and show you how to replace them. The most common failure on the Eli with the gears is going to be in the center of the machine where the three gears are meshed together. In order to get to those gears, what we're going to do, we're going to start off on the top by taking off the casing, the upper casing, the lower casing, the propeller, and then working our way down. We also want to remove the plastic covers that cover the gears, as well as the clear plexiglass spacers at all the relative points. Once we get to our gear, we're going to work our way from the top to the bottom. We're going to remove this gear here by removing the two set screws and pushing the shaft up. Once the shaft is out of the way, we can go to this gear here and remove the two set screws. Once the two set screws are removed here, we can push this shaft in this direction, giving us way to this gear. We're going to come down to the middle here on that same shaft, remove the two set screws, push the shaft up out of the way, and then we're going to come over here and take this apart, pull the cover off, pull the spacers out, remove the gears. On this gear here, right in the center, we're going to remove the set screws from this and push this shaft out away from the center of the machine. And then we'll be accessible to this gear here. Once we're at that point, we want to make sure that we put the gears back on with the shims, the right amount of shims, so that as the gears go together, they mesh correctly. We don't want any play between the teeth of the gears. And then we just work our way back up the machine, shimming underneath each of the gears, again, to make sure that the gears mesh correctly. And then obviously when we get to the top, we'll just put everything back together.
the board I have here is called the black box sensor board, and that board is located just above your CPU card. And we're going to look at some of the features of this board. First off, you have two trim pots. The top trim pot adjusts your duration, and the bottom trim pot adjusts the sensitivity. That's how long that circuit's going to activate your main logic board to let it know the circuit's been activated. And the bottom trim pot is for sensitivity. That's for the circuit back here. When you touch it, it adjusts how sensitive that touch is to activate the circuit. Sometimes you might find that the the piezo buzzer is on the right, and sometimes it's on the left. If you're focused on the sensitivity, you can always remember that it's closest to the IC or in the middle of the board. The two LEDs here to the left of the or to the right of the IC is will light up anytime the circuit is activated. Then you have another green LED on the other side of the board, and that's your power LED. That should always be on. This is your 5-volt regulator here. This is your 12-volt regulator. And this is your main IC, or processing IC, that controls the entire circuit. The board only has 4 wires going to it, and it always forms a pattern like a L pattern, or an L shape. The very first pin on the bottom left corner is your power coming into the board. That should be 24 volts. The pin just above it is your ground. The pin here is your sense wire. This is the pin, the wire that comes out of this board, comes down through the bottom of your bike, and then fastens to the top right corner of this box. The other pin is your sense wire going back from this board to pin 2 of J2 of your CPU board. Okay? The way the circuit works is, and if I wanted to test it in my ride, I can take a screwdriver and stick it in this pin right here, which, remember, that's our sense wire. And if we touch this screwdriver, it's going to activate the circuit. You're going to hear the piezo buzzer go off. You're going to see the 2 red LEDs light up. And then also, if you had your meter, put it on DC volts, go from ground, which is this wire here, put 1 lead of your meter there, take your other lead and put it on this pin here. You're going to see you're going to read 0 volts, and then when you take your screwdriver and stick it in here and you touch it and activate the circuit, it's going to go from 0 to 5 volts. If it does that, then you know your circuit's working properly. If you do that and yet your ride doesn't stop like it's supposed to, first thing I would check is on this, and you've checked the voltage, it's going low to high, meaning 0 volts to 5 volts, then you want to check your dip switches on your CPU board. You have 2 banks of dip switches of 4. It's going to be the bank to the right when you're looking at the CPU board. Dip switch number 3 is probably turned off. You want to turn it on, and it'll probably correct your problem. Okay, this is the black box sensor board that we just discussed. It's always located just above your CPU card, and that's just below your cache box. Now, remember we talked about that that sense wire that comes from here goes down to J2. This is connector J2, pin 2. Okay. And this is the dip switch we were talking about. It's on bank DX, labeled DX. Dip switch number 3, it enables or disables your black box sensor circuit. You want to make sure dip switch 3 is always on. Okay. These dials here, the one to the left is for minutes. It's for your time. It sets how long the duration of your ride. The one on the left is for minutes, so you want to make sure that's on 0. And the one on the right is for seconds, and it's in increments of 10, so we put it on 40. It'll be 40 seconds, but it always ends a little bit longer than that, pretty close to 45 seconds. Just to kind of go over the major components on the board, your volume control is on the bottom right corner. This transistor that's in this heat sink here is your 10 watt audio amplifier. It's a TDA 2006 that you can pick up locally. Your 2 chips here are your audio chips. The one that says Effecta is your the musical one is your one you hear normally when you first coin up. You hear the music, and then when you start to pedal, you hear that other sounds. Well, that's generated from your Effecta chip. Okay, and that's how they get the 2 different sounds. The chip here controls these 2, and this is your main micro. So this main micro tells this what to do, and then it accesses these 2 to generate the 2 different sounds. You have 3 fuses on your board. These 2 that are going left to right are 4 amp. This one and this one. The one going up and down is your 15 amp fuse for your relay circuit to sense 120 to your pump. The one this way is for your 24 volts. If you're blowing this one, what I usually tell people, it could be that you have a catastrophic short on your board causing the fuse to blow on your 24 volt circuit, or it could be something external. Best way to see if it's something external is unhook all your connectors except for J1, because J1 is your power going into the board. Okay, you plug in J1, fuse doesn't blow, board most likely is fine. Then what you do is you plug in 1 connector at a time until the fuse blows. When it blows, then you want to look at your connector diagram sheet, find out what that connector's for, and usually you can find your problem that way. And then this fuse here is for your audio circuit. So if this fuse is blowing, you want to concentrate your troubleshooting in this circuit here, your audio circuit. Okay. The relay that you see up here is for your pump. So what happens is, as soon as you coin up your ride, the relay clicks in and then sends 120 out of this J3 connector. That J3 connector then goes to your base of your ride, which sends power to your pump motor. It also sends 120 to your 12 and 24 volt TR2 transformer. That 12 volts turns on your base lamps. The 24 volts goes to your bridge rectifier in your junction box. Takes that 24 volts AC, rectifies it to 24 volts DC, and turns on the coil of your clutch. That's why when you coin up, that's the only time you see your base lamps, and that's also the only time that you are able to pedal. Okay. One way to sometimes when you're troubleshooting your ride, you coin up, you don't see the base lamps, you're not able to coin it or pedal. One of the things you want to check to see, is my CPU telling the relay to click in, or is my relay bad? Because first thing you'll do is you'll measure between here, but there's only 2 wires on this 3-pin connector, so you measure across the 2 wires. If you don't read 120 and you want to find out, is my board working right, there's a diode just below the relay. Okay, so you want to take your meter, put it on DC volts, take one lead of your meter, go to one side of the diode, take your other lead, go to the other side of the diode, coin up. When you coin up, this diode is in parallel with the coil of the relay. If you get 24 volts, then you know the CPU is telling the relay to come on. Now you know it must be a problem with your relay. Either that, or there's traces on the back of the board that go to this. Your source 120 comes in on connector J1, pins 2 and 8. I might have that reversed. This might be 2 and this might be 8. But it's these 2 pins. That's your 120 supply coming into the board. Then one leg, your neutral side, see, it's these pins right here. And one side is going straight to it. That's your neutral. Then we're switched. This is the back of the. These are the coil of the relay. This is your contacts of the relay. So when your relay clicks in, it shorts between here and here, completing the circuit and sending 120 out to your pump. Okay. So if you read that 24 volts across that diode, here's where the diode was, then you know the board's good. The problem's just got to be with the relay, or those traces, or you're not getting 120 to the board. One of those 3 things. Most of the time it's just the relay, or sometimes the socket. Sometimes there's the contacts in the socket fail, and you can replace the socket or the relay. Okay. And your regulators on the board, you have a 12 volt regulator on the bottom. You have another 5 volt regulator right here. Here's your 5 volt regulator. Remember your TR1 transformer sends 9 and 18 volts AC that goes to connector J1. That's your supply voltage. This is your power supply circuit. You have your bridge rectifier and your filter caps. The only other thing is right down here, it's real important, you have a LED here. When you coin up your ride and pedal, your proximity sensor, which is mounted to the sprocket of your bike, when you start to pedal, there's little holes in that sprocket. And that proximity sensor senses those holes and sends pulses back to connector J6. Your proximity sensor comes from these 3 pins on the bottom row. Okay? First pin on the bottom right corner is your 24 volts constant supplied to the sensor, proximity sensor. Middle pin is your ground. Far right pin is your pulse line. Okay? When you coin up and you pedal, you're going to see this LED start to flash. Oh, that's right. You must plug in your seatbelt. That's part of the circuit. Because these 3 wires, this 24 volts goes right to the sensor, ground goes right to the sensor, but your sense wire goes from here, goes up through the seatbelt switch, and then to the proximity sensor. That's why your ride won't go up unless you have your seatbelt plugged in, because if it's unplugged and you're not getting pulses here, the ride doesn't know to go up. Okay? One of the things you can measure, let's say your LED is not flashing and you want to see but you see the LED flashing on the proximity sensor, it doesn't always mean that sensor is good, because sometimes it'll flash and yet still not be pulsing. So what you can do is take your meter, put it on DC volts, put your middle lead on the middle wire, take your other lead and put it on the far right corner, and then coin up your ride and pedal. If it's not pulsing, then you know you have a bad proximity sensor or a wiring problem from here to your seatbelt switch. Just take one lead meter, stick it there, take your other lead, go to that switch, and if you read continuity, you know your wiring's fine. You just simply have a bad proximity sensor. Okay? Sometimes, if you find that you are getting pulses here, so you know the proximity is good, you know your seatbelt switch is good, your wiring is all good, yet you're not getting your LED pulsing, sometimes the LED itself is bad because it's actually part of the circuit. It's not just an indicator. So if you go to Radio Shack, it's just a general purpose red LED, replace that, and there's a chances are it could fix your ride. Or this NTE 3040 optocoupler. Sometimes it goes that far back in the circuit. And that's about it. You got your crystal. These adjust the volume of the individual sounds, the effecta and the musica. You can adjust the audio separately. And that's about it. Oh, this is connector J4, and that's for your 24-volt valve. So there's two things that happen when you coin up. One, you want to look for the LED flashing. You want to get the pulses here. And then when you coin up and then when you start to pedal, J4 pins 1 and 3 will go to 24 volts. Pins 1's 24 volts constant. Pin 3 is your active line. So what will happen is when you stick your meter leads in there, you won't read any voltage. Coin it up, then you should read 24 volts here. And that goes to the 24 volt valve on your pump. The third thing that will make it go up is you got to have 120 here. So those are the three things that you want to check if your ride's not going up each and every time. Okay, some rides may not have a relay circuit. They may have a solid state circuit that looks just like this. And it'll be in replacement for the relay. And it works exactly the same way. And whenever the circuit's activated, the red LED will light up, and then the transistor turned on and sends 120 to your pump. So if you don't have a relay and you have this, it's the same thing. Your main power from your power cord comes in through the rotation wheel right here. You have your hot and your neutral. Comes up through the center of the slip ring assembly. Your top wheel is your hot, your bottom wheel is your neutral. And then you have these brushes that are constantly pressing against it because of the springs. And this is your top brush, and this is your bottom brush. And they do this because the ride's constantly rotating, so this allows it to safely transfer the power to your other electronics throughout your ride. You have a plastic insulator between the two to keep them from making contact with each other. And this is your ground. Your 120 now comes into your main control box, into this power or routing terminal here. Your brown side is your hot, your blue is your neutral. After it comes out of here, it first sends power to your TR1 transformer, which is always live at 120. If you wanted to check your TR1 transformer, the first two terminals on your left here is your main power, your primary of the transformer. Your first terminal, which is labeled 0, is your neutral. Your hot lead is your 110 terminal here. So if we were to take our meter and measure across that, we would read 110, or close to that. Okay? Now to check the secondary side, which is these next three terminals. First terminal on our left is our neutral line. We place 1 lead meter there. Place our second lead on the terminal labeled 9, and that's our 9 volt output, as you can see on the meter. And we keep our 1 lead at the neutral terminal, take our other one, put it on the 18 volt output, and that's our 18 volts. These voltages are our primary power source to our main logic board located on just below the cache box. And those are the operating voltage for your 5 volts and your 24 volts for your system. Okay. Your next transformer is your TR2 transformer. It too has a primary and a secondary. However, the primary side is not powered until the ride is coined up. And that's because on your CPU board, on connector J3, when you coin up, there's a relay just below that connector that clicks in, sends 120 to your pump motor, and then also sends 120 to the primary of this transformer, which you can measure just like this. And when you do get 120 here, then you're going to get voltage to your secondary, which is 0, which is your neutral, 12, and 24. The 12 volts is your primary power source for your 2 base lamps. That's why your base lamps don't come on until you coin up. Your 24 volts is your supply voltage for your clutch that allows you to pedal your ride after you coin up. You have 5 fuses. They're ceramic fuses that you can pick up at your local hardware store. They're used in breaker panels, and they're different sizes. This particular one is a 10 amp. And if you pop it in, pop it out. F1 fuse is for your TR1 transformer, which protects it from any shorted outputs or anything of that nature. F3 is for your 110 valve. It protects that should that ever short. F4 is for your clutch assembly that allows you to pedal whenever you coin up your ride. F5 is for your 2 base lamps. And then F6 is for your pump motor. So this protects your pump, and that's why it's at 10 amps. And that's all those are for. Then your 120 also routes off of your main input here to a 12 volt AC adapter that's rated at 1000 milliamps. And the only use for this transformer is to supply 12 volts to your relay circuit that's for your base sensors. And we'll go into that a little further later on. The only other thing that your 120 supplies or is a power source to is your Toshiba inverter. Now you have your Toshiba transistor inverter. It's what controls your rotation motor, and we're able to set the frequencies and adjust how fast the base rotates. To look at this more closely, you can remove these 2 screws here and here. And once you do that, you're able to lift this up, and you're able to you have a little access panel door that you open up from the side. Once you open that up, you have another little panel here, has a screw in it, which you can open. And once you open that up, you're able to see the main power coming into it. This terminal right up here on the top is your earth ground. It's tied into your earth ground terminal here. You have terminals down on the bottom. The first 2 pins on the left is your power coming into the box. That's this 120 that supplies voltage to the terminal. And then these 4 wires on the right here is your 4 wires going out to your rotation motor. Same 4 wires that you find right here. Okay. The top terminal here, the green ones, they're labeled. These are the 4 wires that are going to your CPU board located just under your cache box. First terminal here is labeled F. That means forward. R means reverse. CC means command control. And VI is just for your speed control. In the past, we used to, whenever you pedal, the base would rotate a little bit faster, and we don't do that anymore. So basically, this terminal is not used anymore. When you first power up your gain, your left and your right constantly have 16, anywhere from 14 to 16 volts applied to it, and your command control is always high at 14 volts. When the ride, and the reason why we do that is because if you constantly have F and R turned on, the base is going to stay stationary. Once the CPU after you coin up and it wants it to go left or right, what it does is it takes away one of the voltages to either the left or the right, and that's what makes it start to rotate. Okay? So these terminals up here is for your command control from your CPU board that's telling the inverter what to do. If you wanted to test, if you're having problems with your base rotation and you wanted to test the inverter itself, the way you go in, or you want to test your parameters of your inverter, the way you do that is you have several buttons on your front control. One is labeled MON and the other labeled Enter. If you hit the MON button just once, which before I go into that, your normal display should be 0.0. That's what you should always see. But once you hit your MON button, you're going to go into your parameters. And AU1 is the first parameter. The one I want to go into is if you hit the up arrow button, it'll progress through all the different parameters, and then you're going to see a command that says CNOD. At CNOD, if you hit the enter button, it's going to show you the value of that parameter. Currently it's set at 1, but on normal conditions it would be on 0. 0 means that it's going to look for a peripheral device, which is here, to tell it what to do. If you set it to 1, or a value of 1, using the arrow keys, like just now I hit the down button, I changed it to 0, which yours is going to be at. If you hit the up button, it's going to change that value to 1. Then you're going to hit the enter button to save that value. You're going to see your display flash twice. Then if you hit enter again, you're going to see that changed value. Once you're all done, you can hit the MON button 3 times, and it's going to go back to your original setting of 0.0. Now to test to make sure your inverter is working correctly in a manual mode, you can simply hit the run button and it'll start to rotate, and then just hit the stop. When it runs, you're going to see that value 0.0 go from 0 to 8, and that's our normal setting that we have it adjusted to is 8. And that's about it. Then what you want to be sure of, though, after you do that, if you have that command on 1, it's no longer going to see these inputs anymore. So you want to be sure that after you make those settings that you hit the MON button once, hit the arrow button 4 times. You're going to see the command on your display say CNOD. You can hit enter. It's going to show the value of 1. Hit the down button, value of 0. Hit enter. Display is going to flash. It's accepted your command. You want to just verify that by hitting enter again. You should still have the value of 0. Then hit enter again. It's going to go to the next parameter. Then to get out of the test screen, you just hit the MON button until you're back at 0.0, which is your normal operating screen. Your Toshiba transistor inverter operates your rotation motor. When you're testing this and you're going through that command mode that we talked about earlier, if you wanted to check voltages here, the best way is to come off, put 1 lead of your meter on the neutral line here, take your other lead of your meter, place it on inside the wire, making contact to the pin itself. Should read anywhere from 170 to 180 volts AC. Now you may not get it on all pins depending on the rotation of the ride, because the neutral line on the outside pins is always changing depending on the rotations. So if you're not reading voltage on one pin, that may be currently your neutral. Check your other 2, and if the other 2 read 170 to 180 volts AC, then that qualifies that your Toshiba inverter is operating correctly.